Hi everyone, I am going to solve 3.7 example 5 from the study guide. In an RC circuit, EMF equals 12 volt. Resistance is R equals 1.5 mega ohm, and the capacitance of the capacitor in the RC circuit equals 1.8 microfarad. Calculate the time constant. A. B. Find the maximum charge that will appear on the capacitor during charging, and how long does it take for the charge to build up to 16 microcoulomb. Now, if we take a battery, here we have a 12 volt battery. The voltage of it could be shown by E or V, that is equal to 12 volt, connected to a resistor, and then connected to a capacitor. When you have such a circuit, the battery starts sending the charge through the resistor, and the charge will sit on the capacitor's plate such that the capacitor starts charging up. It will start charging up until the capacitor is full, and then it will ask the battery to not send any more charges, and it says, I'm full. So if we want to calculate the charge as a function of time that's sitting on the capacitor, the equation, as we mentioned in the class, it is equal to Q equals Q max times 1 minus e to the minus t over RC. R is the resistance, C is the capacitor, and T is the time. After a while, after a long time, when the capacitor is full, the charge would reach its maximum charge. For part A, they have asked us to calculate the time constant. The time constant, it is equal to R times C. Now, R is given in mega ohm, so you could write it as 1.4 times 10 to the power of 6 ohm. C is given in microfarad, so you could write it as 1.8 times 10 to the minus 6 farad. When you multiply these two numbers, you will get 2.52 seconds. Part B, you're asking for the maximum charge. After a long time, when the capacitor is full, what would be the maximum charge sitting on the plates of the capacitor? Q max equals the capacitance times V, which is the potential across the capacitor. At the moment that the charge is, the capacitor is full, the voltage across the capacitor is the same as the voltage of the battery. So all I will do here is to multiply the capacitance by the voltage of the battery, which is 12 volt. I will get 21.6 times 10 to the minus 6 coulomb. Part C, how long does it take for the charge to build up to 16 microcoulomb? So now I'm going to use that equation for the charge. Q equals Q max 1 minus e to the minus t over RC. Now, for Q, I am subbing in 16. For Q max, I can write it in microcoulomb because I keep Q in microcoulomb. 1 minus e to the minus t divided by 2.52. So you could divide both sides by 21.6, and then you will get 1 minus e to the minus t divided by 2.52. You could switch e to the minus a t divided by 2.52 with that fraction. So I could bring the e to the t divided by minus a t divided by 2.5 equals 1 minus 16 divided by 21.6. Now, in order to isolate for t, we need to take the ln of both sides. Now, ln and e cancel out, you will end up getting minus t divided by 2.52 equals ln of 1 minus 16 over 2.1, 21.6. Now, if you multiply both sides by 2 or minus 2.52, you could find t, and t equals 3.4 seconds.